Today, we're at a car manufacturing factory, and what you see here are different parts of a car. Here's an engine, the gearbox, the headlights, the mirrors, and the brakes. All these and many more parts are put together to make a car. But each of these parts is also made up of smaller parts. For example, the engine consists of a spark plug, piston rings, crankshaft, connecting rod, sump, and valves. So, basically, many small parts are put together to form bigger parts, and the bigger parts are put together to manufacture a car. Here's an algebraic expression. An algebraic expression is a mathematical phrase that contains ordinary numbers, variables like x or y, and mathematical operators like add, subtract, multiply, or divide. This expression consists of three parts: 5xy, 3y, and 7. Parts of an expression which are formed separately and then put together with operators like addition or subtraction are known as terms. So, 5xy, 3y, and 7 are the terms of this expression. These terms are formed by multiplying variables and numbers. Let's look at the term 5xy. This term is made up of a number 5 and variables x and y. Then we have 3y, which is a product of 3 and y. And finally, we have 7, which is a constant term as it has no variables. The smaller parts like 5, x and y in a term 5xy are called factors. So, factors combine to form a term, and terms are put together to form an algebraic expression. We can see that one of these factors may be a number like 5, and the others could be variables like x and y. The number is called the numerical coefficient or just coefficient of the term, while the variables are called the algebraic factors. Hence, we can say that in 5xy, 5 is the coefficient of the term and x and y are the algebraic.
Problem. 3 added to a number gives us 10. Find that number. We know it's 7, but that's not the reason why I asked you this question. I want to know how can we represent this problem in a simpler way. We can probably say x plus 3 equals 10. Find x. 3 is added to a number to get 10. We just assign a variable to that number. This is called an equation, and it helps us write large problems like these in a shorter way. This equation has just one variable, which is x, and it's an unknown, and the highest power of x is 1. These kinds of equations are called linear equations in one variable. They're also referred to as first-degree equations in one variable. They are called linear or first degree because the highest degree of the variable is 1. We will have a deeper understanding of why such equations are called linear in the coming videos. We categorize an equation into three parts. We have an equality sign in the center. To its left is the left-hand side, which is shown here as LHS, and to its right is the right-hand side, shown here as RHS. The problems for such kind of equations require us to solve for the value of the variable. There are two ways in which we can solve the equation. The first method is called the inverse operations method, and the second one is by using the transpose method. Both the methods give us the same answer. But after we solve equations using both the methods, we will realize that the transpose method is preferred over the inverse operations method.
A linear equation is an algebraic equation in which each term is either a constant or the product of a constant and a single variable, where is the highest power of the variable is 1. Here we are going to solve a linear equation in one variable using an activity. Here the rectangle is x, triangle is x by 2, and white counter is positive orange counter is negative when both negative and positive forms 0. Now let's see an equation. X plus 3 equal to 6. Let us see how what is the value of x. X is the rectangle over here, and 3 counters positive plus 3, so 1 2 3. Okay, x plus 3, 1 2 3, okay, equal to 6. 1 2 3 4 5 6. Now we'll keep minus, here it is 3, so we'll keep minus counters, 3 minus counters. Here also 3 counters. Okay, so as we are told here, plus and minus forms 0, so this will be cancelled. This becomes 0. This pair also becomes 0. So h is equal to how much? 3. You got it? So we found that h is equal to 3. Yes, we will do one more problem. X by 2 plus 4 equal to 6. So x by 2 is a triangle plus 4 1 2 3 4, and to the in the right hand side it is 6, right? 1 2 3 4 5 6. Now we'll give negative counters in the left hand side. 1 2 3 4. The same way we will give in the right hand side too. So here it forms. We know that plus and minus becomes 0. So also becomes 0, has become 0. Okay. So what is left here? 2 counters, right? Now what we have to do is that we'll add, if x by 2 equal to 2, then we'll add one more x by 2. Okay, one more triangle into it. So here if it is x by 2 plus x by 2, then here it will be, we have to add two more counters, right, positive counters, so that becomes x is equal to 4. You got to know how x by 2 and x by 2, what is x by 2 plus x by 2? That becomes 2x by 2. 2 get cancelled, so x is equal to 4. Let's do some examples. Example 1. Find the solution of 7x minus 9 equal to 16. Solution: 7x minus 9 equal to 16. Step 1. Add 9 to both sides of the equation. 7x minus 9 equal to 16. We have to add 9 to both sides of the equation. So the minus 9 plus 9 becomes 0. So 7x equal to 16 plus 9, 25. So x is equal to, now we have to eliminate 7. So step 2, divide both sides by 7. So 7x by 7 equal to 25 by 7. 7 get cancelled. So h is equal to 25 by 7.